So in this video, we're going to talk about how to model exponential functions. Previously, we've modeled linear functions as well as circular functions. Linear functions and exponential functions are probably the two most common types of functions that occur in natural phenomena. So what makes a function linear, as we previously talked about, is as a constant rate of change, or that it has a slope. And that just means as the input increases by 1, the output changes by the same amount. And that's just going to be this value in the function m for a linear function. Then we had a vertical intercept in a linear function b. Remember, that vertical intercept is just the output when the input is 0. What makes a function exponential is that it has what we call a proportionate rate of change. And we're going to talk about how to use that proportionate rate of change to find the growth factor b. B is driving that proportionate rate of change. Then, much like a linear function, we have an initial value of vertical intercept, but this is going to be this a value here, and that is just the output when the input is 0. So the key thing I want you to get here is that we recognize a function is linear when the output has a constant change. We recognize that a function is exponential when the output is growing proportionately. So let's look at two tables. In table A, we have inputs x and outputs h of x. And what I want you to notice here is that as the input increases by 1 over and over and over again, as these inputs are increasing by 1, the outputs are going down by 6. Each one of these has gone down by 6. So every time the input increases by 1, the outputs are decreasing by 6. This is going to be a linear function. So h of x is going to be in the form mx plus b. M is the amount the output changes as the input increases by 1. Since as the input is increasing by 1, the output is going down by 6, the slope is -6. B is the vertical intercept. It's the output when the input is 0. When the input is 0, the output is 14. So B is 14. So we know this is a linear function, and it's going to have the formula h of x equals -6x plus 14 when we fill in m and b. Let's look at part B. X is our input and I of x is our output. Notice here as we increase by 1, these amounts in the output are not increasing or decreasing by the same amount. They're actually going to be increasing, or actually they're decreasing in this case proportionately. So this is going to be exponential. So this function is going to be in the form I of x equals a times b to the x. So we need to find b and a. To find b, we look for a proportional change. We take a future output and divide it by a previous. And so here, if I was to take the future output of 12.6 and divide it by the previous one of 14, it should be equal to 11.34 divided by 12.6, and so on and so on. If you take each one of the next outputs and divide it by the previous one, you'll see that each time you get 0.9. That's our value of b. You're actually multiplying each time, each one of these by 0.9 to find the next term. So here b is 0.9. A is the initial value, It's the output when the input is 0. When we're inputting 0, we're outputting 14. This function is going to be I of x equals 14 times 0.9 to the x. So previously, we had taken points and written linear functions. So we're going to review how to write a linear function, and then I'm going to show you how to write an exponential function. So here our output is P of t, and we're inputting t years since 2000. So P of 5 means 3.789, that in 2005 the population is 3.789 thousand, and so on. So if we're asked to write a linear function, we know we're going to try and write some P of t equals m times t plus b. When we wrote linear functions, we found m first, and we worked backwards to find b. So to find m, we do the change in outputs divided by change in inputs. So to find the change in outputs, 5.425 minus 3.789 over 10 minus 5. And if we compute that value, we'll get 0.3272. So that's our slope. P of t equals 0.3272t plus b. We want to work backwards and find b. So pick an output and an input. So let's pick an output of 3.789. When we input 5, we're going to use that to work backwards and find b. So 3.789 equals 1.636 plus b. If we subtract that over, b equals 2.153. So now we can write out the full function. P of t equals 0.3272t plus 2.153. So that would be assuming this function's linear. Let's look at what happens if we want to write an exponential function. So we're going to use the same data, and we're going to write this as an exponential function. So if it's exponential, it's going to be in this form. P of t equals a times b to the t. And the process is sort of similar to a linear function. We're going to find the thing that's driving it first, but instead of finding the slope, we're going to try and find the growth factor b. So to do that, we're going to use the proportional relationship, but now instead of increasing the input by 1, I'm increasing the input from 5 to 10. I'm actually increasing it by 5. So I just want to recall a quick exponent rule that we're going to use. If you have x to the a over x to the b, that is really x to the a minus b. And you'll see why that's coming in handy in a second. So what we're going to do is we're going to use the proportional relationship of the future output, 5.425, divided by a previous output of 3.789. However, that output of 5.425 came when we inputted 10. When we inputted 10 into the function a times b to the 10th. And 3.789 came when we inputted 5. So a times b to the 5th. So we're just using the fact that there's a proportional relationship here. A few algebra things are going to happen. First of all, a over a would essentially cancel out. And now we're going to use this exponent rule. B to the 10th over b to the 5th is equal to b to the 10 minus 5, or really b to the 5th. Then to undo any root, since it's b to the 5th, to undo that exponent, we need to do the 5th root. And you'll see on the video below, I find this value using the graphing calculator. So you can find special roots on your graphing calculator. When we find the fifth root of this, we'll get 1.074. And again, I encourage you to look at that calculator video to see us compute that value. So that's B. Let's plug it in up here. So we're almost there, but we want to work backwards much like we did in the past to find A, the initial value. So I'm going to use one of these points. So I'm going to pick P of 5 equals 3.789. That means the output is 3.789 when the input, T, is 5. So now we can compute A. Since that's multiplication, we're just going to divide each side by 1.074 to the fifth power. And again, you'll see me compute this value here in the calculator video below. We're going to do 3.789 divided by 1.074 to the fifth into 3 decimal places. We'll get A is 2.652. So now I have A and B, and I can write this complete function, P of T equals 2.652 times 1.074 to the power of T. Remember, we could also write this, if you prefer, in parentheses. Those are essentially the same. So now we have a function that will allow us to find the output for any year since 2000 if this data is exponential.